CK. Tonight we're going to build another Eurorack module. This one is from Duskwork.net and it's a self-tuning VCO, voltage controlled oscillator, full do-it-yourself kit. It happens to be serial number 73, so they haven't made a lot of them. We'll take a look at it, see how it sounds. Should be fun. So it's a little box. It's got a QR code on the back to get the build guide. And this DIY kit was packed by Duskworks, Cambridgeshire, UK, and a good contact email address, which is nice. So why don't I go ahead and scan the QR code right now. Okay, and this is version 3, and here it is. Here's the build guide, and it's got the bill of materials, tools required, soldering iron. Oh, there's some surface mount components. Ick. Solder, flat blade screwdriver, tuner, side cutters, multimeter, and a USB ISP programmer. I don't think I'm going to, it should be programmed. Oh my gosh. There's a lot of surface mount components on this. Okay, we'll see how this goes. I'm not very good at surface mount, so let's just open the box up and take a look. Grab out our high-speed Wilkinson razor blade that's at least 70 years old. I'll tell you the story of the razor blade sometime, but not right now. Let's see what's in here. Typical Eurorack ribbon cable. Oh, it looks like all the surface mount components are already mounted. Well, what do you know about that? Except for one. Except for the VCO itself. So this looks like it's going to be a pretty rapid build. Let's get this main circuit board out. And again, most of the surface mount components are already on the board. A whole bunch of resistors, some capacitors, bunch of chips. There are 2 chips still not on there, and those are the ones we're going to be installing, hopefully. A couple of big caps, the power connector, and then this connector has got I think that's for programming the chip, but I'm not certain at this point. So it looks like what we're going to be adding to the board, at least, is the chip here and the chip here, and the serial number is also written on the board. On the back are tune switch, LED, fine tune, triangle pot, something pot, I can't read that, another LED, square wave pot, that probably is a sine wave is what that probably is. Output, and octave, I think that's an octave switcher, but I'm not certain. We'll find out. In this pretty little bag is the front panel for it. Self-tuning VCO, tune, status, triangle wave, sol wave, square wave, control voltage in, so that was CV in, and then output. In here we've got 2 little bitty chips, which is again going to be a challenge. I may use my TS100 for that. And then we've got a variety of things, mechanical things. I think I'll keep those bags for something or other. Knobs, knob, switch that looks momentary. Yeah, that's a momentary switch. Input or output jack, input or output jack. A couple of rotaries, rotary potentiometers. A trimmer with a bent leg. And again, the LEDs. So again, the hard part here is going to be doing the surface mount chips. So I have a plan for that. So I'm going to go get my other soldering iron. I'm not going to use the weller on this. Back in a minute. So as I said, I'm not going to use the weller because I don't really have a small enough tip for the weller. I'm going to use my TS100, which if you don't have one of these, go get one. They're really inexpensive. They're very handy, and you can find them from tons of retailers on Amazon or eBay. I use it with this adapter, which is a voltage regulator that I use with a DeWalt power tool battery. This is a 6 amp hour battery. This 6 amp hour battery is going to power this little soldering iron forever and ever. And one thing, as you can see, it's suddenly portable. You have a very, very good quality soldering iron that you can take anywhere with you, and I like that quite a bit. So, the hard part now begins. We're going to be putting the VCO right there. There's the chip. I'll try not to get my head in the camera frame. Make sure we get it oriented the right way. Now, I'm going to use a lot of flux. From everything I've seen on repair and hand assembly of surface mount connections, flux is your best friend. The first thing I'm going to be using the flux for is actually keeping the chip in place while I get the first lead or two tacked down. And of course I'm starting to whisper because it's all delicate there. That should keep it in place while I solder the first couple of pins. I'm moving it up a little bit so they're exactly square on the pads. And the next thing is my thinnest solder. This is what, 0.25. However, it does have flux in it, so it's very, very fine manufacturing of this flux, which is, or this, oops, come on. I hadn't turned the iron on. You can see it's heating up. It heats up very quickly. There, it's at 300C. Even with all the flux on it, I still bridge the contacts. Let me see if I can suck this back off. No. Okay, I pulled it back out. Now let me get my tweezers. And now I've got solder on the pads, which is good. take the excess off the iron. Have I mentioned I'm not very good at surface mount? I'm not very good at surface mount. Okay, I think I've got those down. I think I've got 2 down. Let me take a look at this. Well, I'm a little shifted that way. I want to go a little bit that way. And if you're wondering if I'm burning my fingertips doing this, yeah, I am, but that's what you have to put up with. Oh, my light's at a bad angle. Let me turn this a little bit. And I think those are all on that side done. Let's do the other side and put some more flux in there. Unfortunately, I can't necessarily check conductivity because there are no bare traces, but we'll power it up and see what happens when we get to that point. See, globbing on the flux usually keeps the pins from getting bridged. It'll isolate the solder. That side looks really nice. Who soldered that? Some guy who knows how to do surface mount. Must not be me. I'm double checking this other side just to see if I like it. Okay, that looks okay. Again, I'm not going to be sure until we plug it in, but that's okay. Let me get the next chip out. For me, the hard part on surface mount is not individual pin soldering, it's the initial. It's getting the first pin down on the board. And I think, I mean, if you've done a lot of surface mount soldering, you probably are looking at this and wanting to give me guidance and hints, and that would be appreciated. I think what I want to do is put a little drop of solder on that one, on one pad, before I put the chip down. I don't want to mess up that capacitor that's right there. Oh, that's way too much. That'll be good. Again, we'll get a bunch of flux on here. And of course, this little 2-ounce pot of flux from Amazon, easy to get. Amazon or All Parts or Amplified Parts or anywhere you want is going to have, anywhere you frequent is going to have good flux. Now we can put the chip back on and make sure the dot is where the notch is. And it is. Okay. Should be enough solder on that pad that when I apply some heat, it'll firm itself up. Yeah. Okay, I'm going to do this side first. Mainly because I'm going to have to work around this capacitor right here, and I don't want to set the iron on it, so I want to have the part really stabilized on this side before I work on the other side. Okay, that's that side done. No bridging. I'm going to put a little more flux in here because I may be on these pins a little bit longer. And a little more on that first pin because I'm not certain I got great contact there. But yeah, talking about this TS100 soldering iron again, a couple of things besides the lightweight and smaller chip, because it's the new modern style of having the heating element way close to the tip. The thermal mass here is really good. You get very little dip in temperature when you contact the component, and that's really important to get these particular pads right and get them in and get out fast. So I'm gonna look again here. Okay, it all looks good. I'm going to pause the camera and clean the flux off, but I'm going to do that off camera. Now I'm going to see if I've shorted any of these pins together. There are only a couple areas I'm concerned about, so I'm going to use the fluke, and continuity makes the beep. So if I hear a beep, that's bad. Good. The two I was most worried about, I'm not hearing a beep. That's me. I touched it together there. Now I can't guarantee they're fully conductive, but at least I know they're not shorted together. So what does he say to do next? Now it's time to, yes, trim pots at the top of the board. There's the two trim pots, and he's got a little, let me turn the light around again. He's got a little indicator right here saying here's where the trim pot screw should be. And again, these pins came a little raggedy, so let me straighten them out a bit using my patented needle nose plier technique. So that goes there, and again I'm using this solder pad from Austin MicWorks. I think Microfilm Works. I think I'm just gonna keep putting that link in the description. Time to install the three main pots. These should click into place. Don't solder them in yet. We need the other parts loosely in place so all the panel stuff moves on. So, which pots are these? Okay, it's those pots. There are three pots with a third shaved off for the flat side, and that's what we're putting in now. Next is the fine-tune pot, and he says there's some tabs. Support tabs. I think he means, I think you can see here there's little black plastic extrusions there that I think are the support tabs that need to go flat. I'm gonna put it, gonna take a look here. So yeah, because with the support tab, no, that doesn't look bad. I'm not sure. I'm gonna go ahead and just put it in without clipping anything off. I can always pull it back out. So you can't actually do that. So what he was saying, because as you can see here, we've got the three pins, three holes for the electronic pins, but these are the pins that, like here, clip onto the board, but these, and I think you'll be able to see this, these are actually too broad to go into those holes, so we got to clip those off. And we don't use our lead nippers for that, because you'll damage the jaws. In fact, I'm not going to use my regular. I'm not going to use my regular cutting pliers either for stuff like this. I have a pair of carbide cutters because they're not going to get damaged by this by this lightweight metal. Okay. Let's see how that fits. Because really what we're looking to see is we want it to be the same height as these pots. And it's still a little high because I didn't nip this one close enough. Get a straight edge. Still a little... No, that should be just about fine. I'm going to actually drop the cover plate or the front panel on it to see if it's sloppy or not. No, that'll be good. Take that back off for now. Now we'll put the LEDs in. Again, we're not soldering anything down yet. He does not have the board marked on the LEDs for polarity. That's too bad. I'm going to make the assumption, I'm going to look further in the build guide here. I'm going to guess that positive is up, but I don't know that for sure. Sorry folks. If the LEDs don't work, we'll come back in, and I'm going to leave the leads on rather long, so if I get it wrong, I will have enough lead left over to take it back apart and resolder. But that's a flaw in this board. Needs to have an indication of which side is positive and which side is negative, of course. I mean, LEDs aren't critical, but it would be nice to have them working. Let me bring over my pan of ice to hold this now. And once again, we have the most interesting part of the video. Turning the pan of ice jack screw. Always compelling video. Okay, now we do the two jacks. Oh, I'm going to pull the knurled nut off the top of the jack and put it back in the parts box. Okay, that all looks good. And then I'll have to do the LEDs on their own when we get there. So first thing I'm going to do is screw the panel nuts on for the jacks and the screw. I mean the push button. Now since the jacks are going to take most of the mechanical stress here, since you're going to be putting the patch cords in and out of them, I want those to be flush, both top and bottom. I think that's going to be good. Let me get a pair, get some locking tweezers to put some pressure there. That looks good. Now I'll get some regular size solder. Well, not regular size, it's still tiny, small, but okay, so that's the pots. Now, as what we want to do with the LEDs is, as you may be able to see, they poke through the front panel, and the shoulder of the LED is against the back of the PCB. So we want to make sure they're all fully forward. Yeah, they're all fully forward. And we'll put it back in the vise. Okay, and as I said, I'm not going to trim the LEDs yet because I'm not sure they're oriented correctly. So, that's the assembly. Very, very, very straightforward, simple assembly job. So now we're going to get ready to power this up. Okay, so we're going to do our typical lash up out here. I've got the output of the VCO attached to the custom guitar amp, which is not the best thing to use, but it's what I happen to have out in the garage right now. So we'll be listening through that. And as we go over to the desk, Eurorack power supply from Frequency Central out of the UK that I bought and built a couple of videos ago, maybe four videos ago. You can go back and look at it. It's a real nice unit. Let's plug the cable in, and of course it's Eurorack, so it's designed for dummies, so it says stripe. Pins lined up, socketed. I'm going to go ahead and put this in the pan vise again for stability. I'll get into the power supply, and now we'll power up the power supply itself for a quick smoke check. Well, it makes noise at least. So we've got noise. Let's do a little tuning. So basic functionality is right. Don't worry about CV input or output yet. We need to calibrate the 1-volt rail by using the top right-hand trim pot. So let's flip this over. And top right-hand trim pot, I'm going to assume is that one. So just beneath the 10-pin power header is supposed to be, he's telling me something, but I don't see what he's saying. Just measure across the 1-volt and ground, which are located just beneath the 10-pin power header. I'm not sure what he's talking about. He needs a picture of this, because I can't see what he's talking about. Because here's the 1-volt. But obviously it works. Very quick build. Except for the surface mount chips, it's a very easy build. And it sounds nice. Unfortunately, again, I still don't have a CV input out here. I got to build that next. So I had a good little chat, or actually an email from the creator of this module over at Duskwork.net, and he gave me some places to look and answered one of my questions, and I got this test lead all mixed up and everything, so let me get sorted out. So the first thing was, where do we measure the 1 volt that the device needs for self-tuning? And as I read to you in the instructions yesterday, it says to measure across the 1 volt and ground, which are located just beneath the 10-pin power header. Now the 10-pin power header is here, so I was looking in this area where the test points are really here. It says 1 volt here and ground here. So they're not quite, again, to my brain, I didn't associate around the power header with that spot up there. So now that we know, we'll go ahead and put the meter on it and see what voltage we're getting at this point. Let's see, I'll even move the meter so you can see too. Hold on. And that is showing, you can see it better than I can right now because of that viewing angle. That's showing 1.65, which is way too high. So let's back off the trimmer. I'd say 1.00 is A-okay. Good. So we've got a good solid 1 volt there now. That is appropriate. Then as to not getting the square wave output, he indicated that the first things to check would be, where's my pokey thing? Pin 4 on this chip, so that's 1, 2, 3, 4, is where that signal will be driven. So I didn't see anything. Of course, again, with surface mount, it's so hard to tell if you've got an actual connection or not. So I didn't see anything out of place, but I went ahead and reheated the pin anyway. So we'll see if we can get that to work tonight. I've already got it plugged in, obviously. If we were reading the voltages, of course I have it plugged in, you idiot. So I just have the amp turned down. And I also have the scope hooked up. So that's a nice sawtooth wave. I'm going to increase the mixer, which takes up the amplitude on that. Now I'm going to go ahead and do, that's a triangle wave, what am I talking about? Now I'm going to bring in the sawtooth. Nice and crisp. The peaks and valleys, let me increase this a little bit. Let me increase the vertical a little bit. Nice clean drop-offs. Now I did, as I said, I did touch up the square wave pin, so we'll see if that is coming in now. No, I'm still not getting anything, and I am not seeing anything on the LED either. Another thing he suggested I check was the potentiometer itself to see if that's bad. So I'm going to turn off my desk light here and go to the overhead camera and turn the volume on my amp down a little bit so you can see that as you bring up the value of any of the components, the orange LED associated with that wave comes up. So now I'm going to come over here, go back to the oscilloscope, and turn the volume up a little bit on the amp. And we're going to go up a quarter on the triangle wave, maybe a little more so you can hear it. And then I'm going to bring in about the same of the sawtooth. See, the more saw you bring in, the less of the trailing leg of the triangle wave you get. And then I'll bring in more triangle, take it back. So it's a good synth. I like it. I like the characteristic. Now I just did a little tuning on it. I'm going to hit the tuning button, which goes ahead and resets it to where I was, I guess. We're full up on triangle and sawtooth, full up on square, and I'm still not getting anything. So, I don't know what's wrong. I don't know what I did wrong to cause that. I'm sure it is my fault in something I did, but that's okay. So, we've got a good solid sawtooth. I mean triangle wave. What, I keep saying that wrong. A good solid. So we've got a good solid triangle wave and a good solid sawtooth that we can tune up and down. Again, I don't have CV to be able to set the octaves. I don't have CV out here to set the octaves, but I'll do that in the future when I build my CV module out for my setup out here in the shop area. I'll go back and tune this to make sure the octave's right. But it's a good unit. Again, I like it very much. It'll be fun to play with, and I appreciate the fact that Duskwork got back to me very quickly about things to take a look at, so that was great. And thanks for watching. Okay, so now we're ready to rock and roll with this unit. As you can see, I've got it installed in my Eurorack workshop test rig, which I built today. I didn't have one, so I figured I'd build one. And we are going to be using it with Logic Pro. As you can see, it's sending MIDI signals out right now. And theoretically, we'll hear it through that custom amp I built a couple of months ago on the floor. Because the MIDI thing I'm going to be feeding into this Duskwork oscillator. We'll bring the triangle wave up. Bring the saw wave up.